So when we talk about radio access network, no, this deals basically on your device, the cell site in itself, going towards the controllers and of course to your core network. But basically this morning we're gonna understand about how ORAN had evolved from a conventional network, okay, towards a open run kind of solution. So we're gonna undertake this morning about the introduction of a radio access network, the wireless telecommunication system component. What are the different network elements? And also the electromagnetic spectrum. So we'll review what are the components of this electromagnetic spectrum and also understand those belonging to the ionizing element and the non-ionizing element. And likewise, also, we're going to have deep dive on the radio access network in itself and some learning key point. And then, of course, part of the discussion would be how we would be able to evolve the technology from your 2G, 3G, 4G, and then 5G, and where Open RAN will fit in into this evolution. Okay, let us go through the introduction on the radio access network. So there you can see this is what you call drive test. So it's a representation of the coverage of a certain mobile network operator. So this is embedded into the map or Google Map, and then the signal bars that you can see below are the different technology where this drive test represent. Okay, so basically the location and distribution of the radio access network site or cell site we call, okay, correspond to a specific technology that are active or activated. Okay, so you can see each plot or color combination correspond to what we call signal level or signal strength. Okay, there's another coverage plot, or should I say there's another representation, another drive test that will represent now your signal quality. Okay, so these are two different parameters that will indicate what is the signal condition or signal strength in a specific area where you are currently staying, okay, assuming you stay in Pasig. And then, of course, another parameter that will represent now the signal quality, okay, or RX1. So the color you can see represents the technology. So let's say in Pasig, you can see there's a 5G already in Pasig area. Actually, Pasig is the first recipient of the 5G, activation of 5G network. So of course, recall, let's have a short recall. 2G, voice and SMS. 3G, which is a sunset technology na. So the reason why operators are deactivating 3G on the premise that it's capacity limited. So might as well refarm those frequencies into 4G LTE for us to be able to maximize the available bandwidth. And of course, the feature set is much more efficient to use. You can access data or the internet much faster as compared to 3G. And then 4G, we have also the voice and the data service. So what do you call the voice service in LTE? We call that one voice over LTE. Okay, and of course, your 4G LTE accessing now the internet. And it also has a parallel equivalent when you are using your Wi-Fi. So we call that one voice over Wi-Fi. So that's with the assumption that your cellular phone or your smartphone is capable to operate on a voice over Wi-Fi network. So you need to click a parameter in your cell phone in the settings for you to be able to operate the voice over Wi-Fi. But of course, the operator should offer it also as a service. And lastly, 5G. So 5G is just a recently activated technology for you to be able to access the network on a much faster speed But wait, they're small. So more than the speed which is offered through what we call enhanced mobile broadband. So there's another two services that is being offered in 5G. So one is the ultra reliable low latency. So this is for a robot or low latency savvy devices or application. And then the other one is the massive machine type communication, which is for our sensor. Okay? So the Internet of Things. These are the things or the elements that will operate on a massive machine type communication. So still in progress, and most operators are still searching for what we call the killer app for 5G. Okay, so beyond that, so assuming you are in Antipolo, so in Antipolo area, there are spotty areas where there is 5G, but majority are 4G and of course 2G signal. Okay, maybe you're wondering what's 4G plus. Okay, this is the LTE Advanced, a much enhanced feature for our LTE. But of course, beyond that is the capability of your antenna where it can operate now on a multi-stream of signal. Okay, when we say multi-stream of signal, it means that it caters more subscriber. You can latch on the internet on a much faster speed. Okay, moving on. So let's further understand what are the different elements. So as I was saying earlier, the radio access network covers now your device or the user terminal. Okay, that's your handy phone. And then via air interface going to your radio access network that comprises now of your base station, okay, or base transceiver station. That's your cell site, where it contains now your antenna element, cable system, radio remote unit, baseband unit, going to the radio network controllers. Okay, before it traverses now towards your core network or the media gateway. Okay, so your antenna operates on the technologies that is defined by the mobile network operator. So multi-technology, multi-beam, and now we have a MIMO antenna. Okay, multiple input, multiple output. It can work and operate on multi-streams of signal from your 4G and of course your 5G network. So this one, okay, will now be connected towards your radio remote unit. That's where the RF signal is being produced and emitted by your antenna, transmit and receive towards the subscriber. And of course, going to the baseband unit, okay, that's the one responsible, okay, in producing now your baseband signal to where your intelligent information or packets of information will be converted towards a analog signal and be streamed towards your antenna and out to the subscriber. Okay, so the map that you can see on the left side is pertaining to the coverage density in the Philippines. Okay, it defines now where there is a signal provided by the operator, either Globe or Smart or combination. I think it's combination, this one. Yeah. And the rightmost is where it's the same as the one I projected earlier. It represents now the technology. Okay, where it's active in these specific areas across the Philippines. So the sources are here, the lowermost portion. All right. So going to your radio access network, okay, there are different transmission media. Okay. So transmission media can come into the form of a microwave, fiber optic, Okay, of course, we are retiring already our copper network that can also be used as transmission media. And lastly, of course, via the satellite technology. Okay, that's your VSAT using your geosynchronous Earth orbital satellite. Okay, so moving on, as you can see on the upper left corner, no, the radio access network is connected now, okay, through a backhaul either on a fiber with the specific IP addresses towards your core network. Okay, so your core network is the one responsible. It's like switch, okay? Is the one responsible to route where you are calling, where you are accessing, what domain you want to access. Okay? Everything is in the core. Also, this is where the database, okay, of all our SIM card, both the HLR and the VLR are interconnected. Okay, and also this is the one responsible now in databasing all our SIM card number, your VLR and HLR. Of course, on a higher technology, HSS ang tawag. Okay? So you have your user terminal. That's your cell phone, okay? Or user equipment. That's responsible to transmit and receive information via 2G, 3G, 4G, and 5G. Okay, that's your smartphone. We call that one user terminal. Of course, on a bigger picture, user terminal can also be in the form of your device, of your sensors, okay, that are able to connect to the network. Even your tablet, your laptop that's capable to connect or to bridge you towards the cellular network. And of course, your radio access network. That's the one responsible now to transmit and of course to receive the information that you want to send out, or especially when you conduct what we call transaction. Transaction can be in the form of voice call, sending SMS, accessing the internet. And then this is via your air interface. So, of course, your radio frequency will be transmitted back and forth depending on the availability of the site. So sometimes you experience when the condition is really so bad that you cannot access your network, either congested or there is an interference. So of course, RF is RF. It's an electromagnetic wave that can travel, okay, towards the air. And along the communication channel, remember your communication system. Okay, within the communication channel, there are unavoidable circumstances or phenomenon, what we call interference or distortion. Okay, so as you go further from the site, your signal weakens or it attenuates. Okay, like Doppler effect. So when you shout and you are nearer to the one shouting, then you can hear clearly, loudly the voice. As you go farther away from the source, the signal weakens, the voice signal weakens, and sometimes if you're a bit far, no, you can barely hear, okay, and understand what the message is. So what's the goal of the communication system? Our primary goal is to efficiently send the information, okay, and it should be understood by the one receiving it. You need to convey the right information, and in so doing, your communication should be properly designed, okay, that will meet the specific parameters required for the communication system to work properly. Protocol is the one responsible in governing all the different parameters so that each and every one, each and every network element will have what we call handshake. Okay? So that each element will be synchronized and they are interoperable with each other. And that's the basic rule when we implement sooner or later Open RAN. Okay, each element should be interoperable with each other and should have the handshake, which is governed by what we call protocol. Okay, so your base station can operate on a 2G technology, on 3G, but of course 3G we shut it down because it's a sunset technology, same as WiMAX before, no? Because of capacity limitation. And then of course, we call that the base station of 4G as eNode B. And lastly, your 5G network, we call the base station as your G Node B or next generation Node B. Okay, and of course, you have your core network. That's the one responsible now in switching, okay, a specific route where you're gonna go. And it will direct you to the PLM address of the person you're calling, of the device you're calling. Assuming your mobile calling a wired telephone set, or your cell phone calling to another cell phone. Okay, so the switch is the one responsible in authenticating, okay, in managing, synchronizing each and every transaction. Okay, so we'll go on to the next slide. Sorry, before we go, I would want to emphasize also on the one I discussed earlier, no, on the backhaul. So we have microwave, can be on fiber or copper, and then lastly on satellite. Or microwave can deliver up to 1 gig or even 2 or 3 gig at maximum, depending on your distance. Because the same concept, the farther you are away, the link from each other, no, the modulation technique will be downgraded. Okay, so the nearer you are, the better is your modulation technique. Okay, it means the faster you are delivering the information, higher throughput. Okay, take note that in microwave, these are also sensitive, especially when there is a heavy rain. Okay, fading is something that we cannot avoid, but we can intervene. Okay, and we can address by, delivering redundancy, okay, or diversity. And then another is fiber. Of course, they say it's a lossless kind of material, but of course, within a specific distance, you need a repeater in between. Okay? So, because this is via line. So, 10 gigabits per second in most of the sites, especially on 5G, is the major capacity, backhaul capacity required to have a multi-technology and integrating different sites. And for you to be able to manage also the capacity required, especially in those areas that are high traffic. Copper, okay, this is the one that we're using for wireline network, but it is also applicable to be used as a mobile backhaul. And lastly, your satellite. Of course, with the advent of technology, I'm sure you're gonna ask me, how about the use of low Earth orbit satellite? Of course, most operators across the globe are also exploring this one because the nearer you are to the Earth's crust, okay, the lower your latency is. So LEO compared to MEO, mid-Earth orbital satellite, and then your GEO, synchronous Earth orbital satellite, which is really very far away from the Earth's crust. So it means that your latency is very high. And of course, what does that mean when your latency is very high? Okay, you cannot stream, okay, video, live simulcast. There are delays that you will experience, unlike when you go on the low Earth orbit satellite. Okay? So, sorry, let me get back. Okay, so from user terminal going to your radio access network is via air interface. And of course, from your radio access network going to your core network, um, there is what we call backhaul, the one that I discussed earlier. Okay, this can be in the form of fiber, via microwave, via copper, and of course, via your VSAT technology or satellite technology. So of course, expect more emerging technology that will come along, okay? Because technology really is very fast, and let's maximize it. All right. So I'll proceed on defining what is spectrum. So it's a fundamental asset, okay, that provides now your wireless connectivity. So it's an invisible electromagnetic wave generated by radio transmitting device, which is your handy phone. And then of course, vice versa on the other side, your antenna will be the one responsible on transmitting and of course receiving the information being sent by the user terminal. Okay, our spectrum is subdivided into different classifications or categories. From the lowest operating frequency, that's your 60 hertz, okay, that is generated through the electricity in a power line. Then going up to your radio waves. Of course, there are very low frequency along the way. And we go on towards the area of discussion, which is your radio waves and microwave. And then within the visible light is where your intersection of the category where it belongs to non-ionizing radiation elements, and those anything above ultraviolet spectrum, going X-ray, gamma ray, these are ionizing radiation. And of course, when we talk about non-ionizing radiation, it means that it doesn't have that enormous amount of energy to break into the subatomic level to sustain the energy to become radioactive. Unlike the ionizing radiation element that is really dangerous, of course, when you go on exposure to too much gamma ray or even X-ray, then it causes cancer and your cell will die. Okay, ionizing radiation, it means that it has this very huge amount of energy on a higher energy level that breaks into the atomic level, subatomic level, and it creates now like a self-sustaining, okay, radiation. So that's pretty dangerous. That's why it's very dangerous for us to really walk during daytime, especially when the sun is up that high and so hot. Okay, like 10 o'clock going to, I think it's 2 p.m., no? So that's why, if possible, you bring your umbrella to somehow protect you also on the sun's ray. Now, take note that on the context of regulation, no, this is the one that mobile network operator, okay, they acquire this spectrum license and we need to pay a specific spectrum user fee, okay, for us to operate this license, or we be given the license to operate, okay. And of course, this is the one that we pay to the government through the National Telecommunication Commission. So yeah, licenses are normally 10 to 20 years in duration for a mobile network operator to utilize. Okay, so we pay this what we call spectrum user fee. Then of course, these are the cellular frequencies in the Philippines. Okay, so a representation now on the different spectrum band. Okay, so of course, what we use are 700 megahertz for LTE and even 850. And then 900 for GSM and UMTS or 3G. Now it's refarmed to be used for LTE. And of course, likewise on 700 megahertz. Okay, so this can also be used in the future for 5G. Then the 1800 megahertz, this is currently used for both 2G and 4G. And then, of course, the 2100 megahertz that's previously used for 3G now, it's currently used for LTE. And of course, the 2300 megahertz for LTE and the 2500 or 2600 megahertz also for LTE. But it's currently used also for 5G. And then lastly, the 3500 megahertz. Okay, this is currently used for 5G. Okay, so nonetheless, the rest, they are being used for other application but not used by the operator, by the telecom operator. So the 450 megahertz, now it's not being used because there are other taxis who are utilizing this one. So there are a lot of interferences across the country. Okay, so this slide shows you now the different modes of operation of our phone traversing towards the cellular site. We have frequency division duplex. It means that you have an allocated channel on the uplink and another different channel on the downlink. So they simultaneously work and streamed, okay, both ways on the uplink and on the downlink because there is an assigned channel, okay, different from each other on the uplink and on the downlink. Then we have also what we call time division duplex. So the time division duplex, okay, at a specific time period or a specific time instant, okay, the packet flows or operate either on downlink or on uplink. Okay, so as at T0, it can be that downlink is currently in operation. And then at T1, okay, we have your uplink. T2, you have your downlink. Okay, so vice versa. Okay, or some can be combination of the two depending on the allocation. Okay, so of course, this one is also related to your earlier slide, which is your frequency assignment. Okay, so if the channel or is the spectrum is belonging to a frequency division duplex kind of transmission mode, okay, which are the 450, 700, 850, 900, 18, 19, and 21. So this is on a FDD mode. And then the rest is on the TDD mode. Okay. So for a better understanding, no, just a zoom of the network architecture, okay, of a simplified version. You have your user terminal, which is your cell phone. And then depending on whichever is the best serving site, so that's where your cell phone will camp. Assuming that you are in between the two cell site. So where do I camp? So there is a specific parameters defined into the network, whether if it's based on the criteria that it should have good signal quality, then that's where the handy phone will come. Okay, of course. And if another parameter to consider could be whoever has the strongest signal. Okay, so that's where the handy phone will come. So as you move from one place to another or you're driving, your handy phone will come or be hand over from one side to another. Okay, can be on a soft handover or handover, especially when you traverse to another controller or base station controller, or you are being served by another core network. Of course, core network is not just single facility that will serve now the entire country. There are different location of the core, and there is also a geographic representation, okay, based on the definition of how many sites or how what is the traffic within the area. Okay, I'll just go back to the slide where there is the map. So just for a better appreciation of your core network, the one that will serve now which region. So it can be that there's a one core facility serving now the upper region of the North Luzon, another in the Central, another in NCR and in South Luzon, and within the Visayas and Mindanao, another two or three. Okay, so it depends on the traffic. Okay, because you need to do load balancing. Same concept with the site, no? Okay, if there are many subscriber that is latch into site A, so you need to do load balancing in order that it will be able to handle, okay, this numerous number of subscriber to avoid congestion into the first serving site. So the second serving site can get the load, okay, especially if they are overlapping with each other. Of course, if there's only one single site serving the area, then forget it. So really, it will be congested. So what's the impact of congestion? Of course, it will give you poor customer experience because you can barely come into the network or latch to the network. So that's the difficult part there. Okay. But if, of course, there is load balancing, then you reduce the congestion on the first side and be able to move other subscriber into the overlapping second side. Okay. So in the optimization portion, based on the performance statistics of the site, then you could see and correlate, and then of course do some performance optimization, then load balancing. Okay? But of course, there are certain parameters also we need to consider, to avoid dropping. You need to be sensitive. Okay, so you increase or decrease the sensitivity of the site in order to capture or not capture this subscriber that are currently latched into the two cell site. Okay, your backhaul plays a vital role, of course. It doesn't only, we don't see only congestion on the side of the cell site or base station, but also there is congestion on the side of the backhaul too. Okay, assuming that there are many cell sites that are connected into this, let's say, copper cable that is capable to deliver a backhaul capacity of, let's say, up to 100 Mbps, then there's not that much subscriber who can latch into the area, especially if there is full technology. So that's why operators create what we call the guidelines. Okay? deployment guidelines. So each technology corresponds now to a specific, okay, capacity or backhaul capacity for it to efficiently operate. Okay, let's say for example on 2G. So this is just 12 point, 12.2 kbps or even 24 double it. Okay, so you just need at a minimum of 50 Mbps to cater all other site. Of course, when you operate on 4G LTE, at bare minimum, you should have 100 Mbps or even 300 Mbps, much better. For 5G, you need to have a transport backhaul of at least 1 gigabits per second or even higher, much better. Okay, so that more and more subscriber can experience much higher throughput, okay, or internet speed. All right. So moving on. So what is the radio access network? So this is a part of the whole communication system, okay, or the cellular network where it's responsible now of transmitting and receiving the information. Of course, it provides now the connectivity towards the subscriber. And these are distributed based on radio network planning, which is very vital for you to determine the specific or optimal location of where you're going to build your cell site. Okay, there are a lot of radio network elements now that are deployed from Batanes down to the Jolo region or Tawi-Tawi region. Okay, that provides now the connectivity to the subscriber. So you have a specific criteria that needs to be employed when you do radio network planning. Of course, you need to determine what's your target coverage objective. Okay, how many are the people, okay, located on that area on your target coverage objective, because you will need to define now your capacity. Okay, what is the configuration of the site? What is the technology of the site that you will be building in that target coverage area or location where you want to build your site? Okay, so of course you have your coverage planning. What is the sector? Okay, assuming that you're building a 3-sector site or even at maximum 4-sector, especially in those highly dense area. And then you need to determine, okay, how high the antenna is based on how far you would want to cover. Okay, geometry. Okay, di ba? So the higher yung height mo, the farther yung inclination and yung mako-cover mo. So it means that the higher your tower, okay, the more area you can cover. Of course, that will be applicable on rural area where you really want to maximize, okay, the capability of the site. Else, you cannot build a 40-meter tower within a CBD or within a urban area. That will cause overshooting and more so worse interference, okay, co-channel interference or even inter-symbol interference on 4G and 5G. Okay, because you're creating now a lot of, or you're propagating a lot of signal because your tower is very high. Okay, so these are the parameters you need to consider. Okay, that is very relevant, okay, in doing coverage planning. Of course, you're gonna need a planning tool in order now to view through the coverage prediction produced by the planning tool, how far you can cover, how many, how much in the area can be covered. Then that's Primarily the first part. Now, secondary would be capacity planning. How many subscriber in the area? What is the profile of the subscriber in the area? Okay? And what technology are they gonna use? What cell phone are they gonna use? Okay? What will be the service the operator would want to offer based on the need of the subscriber? So these are the key things we need to consider when we do capacity planning. Okay, take note that you can also do this one in the planning tool through Monte Carlo analysis. Of course, it will just take time because it will load, okay, the subscriber, have some systematic approach in terms of determining how many subscriber would do this kind of transaction, a specific time instant, okay? And then we'll now generate what will be the required um, capacity for you to design in the cellular site you want to build. Okay, what will be now the configuration of the site that you will be building. And of course, that will also be linked towards the transmission part, your backhaul. Because you had optimally designed now your site, but your transport backhaul, okay, is just this very small backhaul capacity, then it will be useless because there's still congestion that will be experienced along the way. Okay, so where can you see this site? I'm sure if you are a traveler, you can see different styles of site, different design. Okay, it can be four-legged self-supporting tower, three-legged self-supporting tower, monopole, guide tower, rooftop, okay? Or it can be braced on the side wall of the building. You can see antennas, or in some area, these are camouflage, okay? So as not to distort, the ecosystem or the environment. So architects doesn't want to see an eyesore type of devices in their very beautiful buildings. That's why operators, they do some sort of camouflage deployment. Okay, so beyond that, on the outdoor, we also have indoor. We call that one in-building solution. So that's where you can see on corporate buildings, malls, schools, where you can see what we call picocell antenna. Okay, that picocell antenna is the one responsible now, similar to the application of your site, of your macro outdoor site. So there you can see in most the panel type or the omnidirectional type of antenna. So there you can see, it's like a hat on the ceiling of the mall. So these are the two kinds of deployment of your site. Okay, one for indoor and one for outdoor. But of course, your backhaul you can see is via microwave, or others they use now fiber. So most operators, their primary deployment is using fiber because this gives you this much capacity needed to really operate on a multi-technology. Okay, so this one second is the microwave that will link you towards another site, which is where the radio network controller is located, or maybe directly towards your central office or your core. Okay, so of course, that's why you have your Instagram or Instagrammable posts, especially when you go on vacation in Boracay, Bohol. So there's ample coverage in the area. So there where you can stream or post your Instagrammable pictures. All right. So moving on is the understanding also on our evolution of mobile communication. So as I emphasized earlier, no, so 1G, this is the walkie-talkie type of technology. It's analog in nature, but of course limited in terms of capacity. I'm very sure some of the viewers or attendees in this morning session, they experienced the first generation network. Okay, so this is based on the AMS, TAX, and NMT. Okay, kind of technology. It's too limited. Okay, it's applicable only for voice call. Okay, then eventually nagkaroon ng beeper where you can receive SMS notification, okay, beep beep, and then eventually your second generation network that's now capable of delivering voice call and SMS, then eventually of course your through GPRS and Edge, okay, you could use it for um, wireless access kind of protocol where a small scale or limited speed for you to access the internet like 100 kbps or even higher going to 300 kbps. Then with the prevalence of technology and emergence of this third generation network, but it didn't work well, no, due to capacity limitation. That's why most of the frequencies being used for 3G was refarmed to 4G. So 3G, this is pure data, okay, at higher throughput going to 2 Mbps, and it evolved into, of course, high-speed downlink packet access or high-speed uplink packet access, or eventually HSPA, high-speed packet access that's now capable of delivering on a dual carrier like 14 Mbps, okay, or less. Then now we have 4G LTE and 5G. So your 4G LTE, this is where you experience now a theoretical throughput of up to 100 Mbps, but of course, most of testing is just up until 24 or even 40-ish Mbps. But with 5G, of course, you can experience 200 Mbps or even higher, especially in those areas where there's not much subscriber yet, but all the available spectrum is given to you, dedicated to you. That's why you experience 500 Mbps or even more. Okay. Just for better understanding, the more subscribers being loaded into the network, the load goes up, your experience will go down, your speed will throttle because your available channel is spread or subdivided, okay, towards the subscriber that is lodged into the network. Okay? Don't conclude na, hi, ang pangit-pangit ni Globe, ha, ang pangit-pangit ni Smart. Please also consider that you're not just a single subscriber. Ang dami nating subscriber na nakalodge sa network, and we share the limited available spectrum. Okay? Please take note of that. So it's very important that for an understanding of this is we have this spectrum. This is shared across those subscribers that is lodged into the network. Okay. So I explained earlier the 5G has 3 services that it offers. Your enhanced mobile broadband, that's why if you have your handy phone with you, and of course you're latching to the network of 5G, so you do speed test, you can see it rise from 100 going to 250 to 400, and even the one in some area 500 Mbps, especially when we launched before, the 5G, you can reach up to 800 Mbps somewhere in Makati, in BGC. And now, since a lot of subscribers are having with them their iPhone, they have their, latest iPhone, Samsung that's capable of 5G, then you are loading this user terminal into the network. So what does that mean? It eats the available capacity or the spectrum, and it will be divided. That's why from 800 Mbps, now you can experience to 50, 300 Mbps. So the more you load, okay, basic concept, your available spectrum will be subdivided to these subscribers or user terminal. Okay, so this is just a representation of the different generation. So we have earlier yung 1G, now we have 2G, 3G, and then 4G, and recently we have 5G. So you can see that on the uppermost layer, the different services that it's offering based on the technology. And on the lower most boxes are the years where these were commercialized. Okay, so the one that we launched way back February of 2020, because that's the commercial launch, and 2019 was the technical launch. So the Huawei 5G phone was presented to the customers in BGC. Then, of course, each corresponds to the capacity needed for them to efficiently operate and for the subscriber to enjoy each and every services for this technology. Take note that the lower the capacity you're offering, in the end, pangit ang speed mo. Or worse, if it's congested, you cannot even go through and avail the network. Okay, so of course, this next slide shows you now the different component. Okay, so in a conventional radio network, you have your antenna system. Okay, you have your radio remote unit. Okay, this is the critical component in the whole ecosystem because it's the one responsible of converting now the radio signal received by the antenna into a digital signal and be processed in your baseband unit before it goes through the core network. And of course, it's the one also responsible of converting the digital signal into analog form once it's being transmitted towards the subscriber. And of course, to reduce the loss between the antenna going to the RRU or vice versa, it should be nearer to the antenna. Okay, so because this will pave the way to reduce now the attenuation. Because if the cable is too lengthy, the coaxial cable between the antenna going to your base station, then you experience a lot of loss. Recall concept, basic law physics, no, on cable system. The bigger the coaxial, the diameter of the coaxial cable, the lesser the attenuation. The smaller the diameter of the coaxial cable, okay, the higher the attenuation. And worse, if you go on far or lengthy cable system, then you really have a huge attenuation. That's why most operators, they use now, the active antenna unit so that your RRU will be much nearer to the antenna, and of course, it uses now fiber optic cable, okay? So that your antenna will deliver optimally the power required to drive and to propagate the signal a bit far, okay, to cover more. Now, your BPU, on the other hand, is located on your telecom room, okay? So this is the one where it's responsible now of processing your signal before it transmit towards your backhaul or transmission media and then traversing towards your core network. So lastly, no, before it traverse going to your core network, so you have your backhaul, okay, either in the form of your fiber optic cable, coaxial, or sorry, VSAT, microwave, okay, or your copper cable. Then observe, you can see on the leftmost, the radio access network between RRU and BBU is what we call front haul. And then BBU to your core network, we call that one backhaul. So the tower structure is dependent on the design based on the load. Okay? Recall your subject on strength of materials or dynamics of rigid bodies. Diba? You have your antenna weight. It corresponds to a specific load in kilonewton, okay, because of the weight. You need to consider also the wind loading. Okay, that's why if you're building a monopole in area where the wind is really so strong, then forget it. There will be structural instability. Your antenna might fall down and tower will get really cut down into two, especially during typhoon. That's why in those region where it's typhoon belt or wind loading is really high, the wind's so strong, then we have to build self-supporting tower. Because in that way, you'll reinforce the weight of the antenna, the wind loading, okay, the stress and strain that's being experienced by the network elements, including the antenna and cable system, then it can withstand, okay, these loads that you're gonna introduce. Okay, so moving on, as you can see for appreciation, no, these are the different styles, design of a four-legged self-supporting tower. So there you can see how each antennas and microwaves are placed. The one that you've seen in ABS-CBN, PTV4, these are broadcasting tower. But sometimes mobile network operators also collocate in those facilities. But they are located only on at maximum of 40 meter and 30 meter, but not putting in all the system into the highest peak, which is 80 meter. Okay, so there's no such kind of terrestrial cellular network that is that high. It's only applicable for broadcasting network elements because you need to really cover much far, okay, for FM, for TV broadcast, and even AM stations. Okay, this is also a sample representation of your three-legged self-supporting tower. So this is a lattice tower, no? They call that one like a crystal, freestanding vertical tower. So sometimes there is a definition, no? If the gantry where the antenna is placed is circular, then kay globe. If it's triangular gantry, okay, where the antenna is mounted through a mounting bracket, then it's smart. Okay, so we also have guide tower. Okay, similar to an AM tower. So there you can see the guide mast. This is to support now the load of the microwave antenna, of the base station antenna, and all other accessories. Okay, that brings about additional load into the tower. So take note that this one, it needs to have a much larger footprint for the guide to be, okay, to be embedded into the soil. Okay, once these are not properly designed, then it will, create now a failure on the stability of the guide tower. Okay. Then we also have what we call monopole tower. So it's a single pole where the applications usually on CBD, villages, because of lesser footprint that it will eat on ground. So you have your base pad, then your monopole. At sometimes it can be implemented at a maximum of 30 meters, but most of the time it's between 15 to 20 meters only. Okay, especially in villages where they don't want to see an eyesore equipments of a cell site. So in some cases, we do camouflage also of the site. So we also have this kind of deployment. We call that one rooftop. Okay, the one you can see on buildings, or sometimes these are camouflage on the side wall of a building where you will not notice that there is a antenna. So when you look up high the St. Luke's Hospital, no, you can see two different types of deployment there. One is the visible rooftop base station, and then our cell site. Then the other one is it's invisible, but there is an antenna. So we painted it similar to the paint of the sidewall for you not to realize that, hey, there's an antenna up on the roof. Okay, so this is the one I cited earlier, the wall mounted or side wall. You put it on a side wall. Or you paint it like the building so that it will not look eyesore. So this one is very obvious kasi. And then cell site on wheels. Yan. This is used for events area, big concert ground, where people gathers. Okay, during disaster response, this is used to address now the need for a site within the area for a signal to be provided on a ground zero. And then we also have camouflage sites. Ayan. There's one in McKinley, okay, in BGC, going to EDSA. You can see a palm tree there, but the leaves are falling already. So that's why, yeah, it needs to be recreated also again so that it will look like a palm tree. But yeah, these are the deployment, especially in areas where they're strict with, the aesthetic of the environment. Okay, as I emphasized earlier, we also have what we call in-building solution. So this is in the form of distributed antenna system, where this panel antenna and Omni are distributed across within the inside portion of the building to provide now, okay, the RF signal for our phone to have full bar. In those buildings where we don't have in-building solution, then these are served by macro serving indoor. Okay, these are macro sites where you beam the antenna towards that building for you to provide now the coverage inside that building. Okay. So this is a representation of your indoor system. You have directional antenna, that's your panel. 7 dBi antenna gain, while the other one is the Omni with 3 dBi omnidirectional antenna gain. These are interconnected through RF couplers, combiners, or splitters, and then traversing towards your base station. So a base station can be multi-technology or single-type technology, but they are combined through what we call multi-technology combining system. Once operator collocate with each other, there will be now a separate combiner room, okay, or meet me room where the multi-operator combining system module is being placed. So that's where Globe, Smart, dito will combine. They used to be Globe, Sun Cellular, then Smart through a 8-way or 12-way combiner. So each cable of the operator are connected or injected towards the multi-operator combining system. Okay? So we also have small cell or picocell site. What's the difference between macrocell, picocell, small cell, or even femtocell? So the difference are basically on the RF power output. Okay, your macrocell 40 watts, or even your in-building picocell, okay, your indoor DAS. And then while your small cell has a power output at maximum of 10 watts or even between 5 watts to 10 watts. Then you have your femtocell, which is the smaller version, okay, 250 milliwatts lang. Good for small office, okay, or conference room, providing signal in those kind of area. And then we also have recently the portable 5G in a box, okay, offered by Singtel, or the private 5G they call. And then Globe recently launched our private 5G network, okay, and we were the first one actually to launch that one, okay, not test, launch, okay, and do pilot testing here in the Philippines. Okay, private 5G is a kind of a family of an open RAN technology because you are now disaggregating from the conventional network and bringing all in a box. Your RF component, your base station with BBU and RRU embedded inside that box, and of course your small core network, and then you will traverse towards the internet. So that's a concrete example of a family of Open RAN. Okay, not just tests with the other operator abroad. Okay, so you can reach out with our account managers, enterprise account managers, if you're interested on this one. Okay, so moving on, no? So sa Philippines, hindi tayo nahuhuli sa technology. Okay, we always go, we always adapt, we always test and deploy. Okay, not just for publicity purposes, but you can see really this kind of solution, okay, to be implemented or being implemented into the network for the Filipinos. Okay, in a traditional network, you can see this is a small cell, okay, or a cell site on a pole solution, where you can see the radio remote unit here, no? Plug in towards the small mid-gain antenna, because antenna have different classifications too. You have high gain antenna, okay, that's the very big one that can boost far, cater more subscriber. You have a typical conventional antenna with a 18 dBi antenna gain. The high beam antenna or high gain antenna, that's the one operating on a 21 dBi antenna gain. And then you have your mid-gain antenna with 12 to 14 dBi antenna gain, good for street level coverage or small type for small cell deployment. And of course, you have your picocell, which is 3 dBi omni and 7 dBi panel. Okay, so this one, no, you can see how it's being deployed on a street level connectivity. So of course, you have the power cable going to a commercial power nearby. So don't expect to have redundancy on that, because once there's brownout, so that will basically be affected. Unlike the big one, the macro site, it has generator set, it has a uninterruptible power supply, so it has backup. In principle, If brownout, you still have 8 hours on the go. Okay, you still have your signal. And then, yeah. So, an equipment from a traditional vendor using a CPRI. Why CPRI is really talk of everyone, no? Because this is an interface. It's a technology that will now interface from your radio remote unit towards your baseband unit. Okay? You can see on a physical layer, okay, LTE transmitting now the decoded information of bits of ones and zero, the digital signal. Okay, it will now traverse towards your baseband unit through what we call radio equipment controller. So you have your user plane, control plane, and lastly your synchronization, clock synchronization. Because if there's no synchronization, then nauuna yung audio mo sa video mo. So same as how the television operate, no? Kikita mo na gumagalaw na yung tao and then after a while, doon pa lang magsasalita. Doon mo maririnig yung audio signal. Okay? So that's why synchronization is very important and vital, especially when you transmit and receive on a TDD mode, okay, and FDD mode. You need to have synchronization so that packets are well synchronized with each other and you avoid, possibility of overtaking one packet to another or delaying one packet to another. No? Tamang pan lang movement of these packets of information. So CPRI, it's a standard defines now a set of protocols. So protocol is the one that governs now the interconnectivity of each and every element. They need to be governed by what we call protocol so that there will be handshaking along the way, no? And this is a much needed parameter for you to successfully transmit and receive the information. Okay, so we also have what we call baseband unit. Yan. So most of the time, no, the baseband unit is located now in your telecom room or even on the lowermost portion, especially if the site is an outdoor type of cabinet. So this is a component of your radio access network that's now responsible of processing and managing, of course, the data that's being transmitted to and from your cell site. And okay, this is, This is also synced towards your microwave. It's via microwave or fiber, okay, for it now to transport the information going to your controller and going to your core network. So these are connected through a fiber optic cable from RRU to BBU and towards the central office. So it communicates now by using the RRU, the CPRI in the RRU, and then it enables a high-speed kind of transmission. Okay, so basically this is how baseband unit works. So let's simplify everything, okay, in a network architecture. So we have, of course, on a 2G, you have your base station, your UE going to the base transceiver station towards the mobile switching center. In 3G, you have your user equipment naman, and then traversing towards your eNode B, or Node B, I should say, and then towards the radio network controller, and then traversing towards the data network. Okay, your serving GPRS support node and your gateway GPRS support node. Okay, this is the one that's responsible to traverse going to the internet for you to access your internet. And then in 4G, you have your user equipment, then eNode B ang tawag sa base station, and then serving gateway. And then going to the internet, your packet gateway. Your mobility management entity is the one responsible, okay, in synchronizing, in authenticating your transaction, your SIM card number, and provides you the gateway towards your cold party or the domain that you want to access. Okay? In 5G, non-standalone. Okay? Because this is still connected, interlocked, towards your enhanced packet core. So this is through what we call your connection of G node B towards your mobility management entity. So take note that you don't have any more radio network controller nor base station controller. Okay? It is routed directly towards your enhanced packet core. Okay? So this is a simplified version of your end-to-end 2G, 3G, 4G, and 5G architecture. Okay, mirroring it, translating it now into what we call open radio access network architecture. Oops, why so many? Okay, you have now the addition of what we call front haul. You also have the addition of what we call mid haul. And then you also have the addition of back haul. Okay? But basically front haul and back haul is part of the conventional network though, but it's more putting emphasis, okay, on this one. So your whole radio access network is subdivided into different network elements from your user equipment to radio unit. Hindi na siya radio remote unit, but rather radio unit. And then you have front haul, putting emphasis on your enhanced CPRI. Okay? So we call that one as an open front haul. It's an open interface of, defined by ORAN Alliance. And then we also have distribution unit. Dati, we just have radio remote unit and baseband unit. Diba? So, the distribution or distributed unit, this is now your real-time baseband processing unit that's responsible on supporting now a layer 2 physical layer with MAC and radio link control functionality. And of course, it's cloud hosted. So what does that mean? It doesn't operate now, the processing doesn't operate on-prem, but can also be through the cloud. Now we also have mid-haul. Ayan, in-expand natin, going to your centralized unit or central unit. Within the mid-haul, interfacing your distributed unit with centralized unit is your RIC. Ano ito? Wala namang ganito diyan sa conventional network natin. So your RAN intelligent controller, it enables a non-real-time RAN management and optimization. So even though you're not connected, on the network, so still it has the intelligence, okay, to process the different activities in the radio access network. Your centralized unit or CU, nasa layer 3 na ito. Okay? So, this is the one now like disaggregating the baseband unit, okay, into two. Okay, pero in principle, baseband unit ito. This is the one that will interface your backhaul or transmission media towards your core, okay, through cloud hosting. So your Open RAN cloud or OCloud, okay, this is a cloud platform for hosting now your distributed unit, your centralized unit, okay, either or on a virtual machine assignment or on a containerized deployment in the cloud. So each Open RAN system are defined on a specific virtual machine, okay, or assigned to a specific virtual machine. Of course, your OCloud is for you can use a general purpose hardware. Ano pa yung mga hardware providers natin? HPE, Dell, yan. You can use all this stuff. Then you also have now your Open RAN core. Okay? So the RAN system, they are often divided now into different layers, the one that I've shown you earlier. Okay? They are defined through what we call open system interconnection model. Okay, for those ECE, during our review, di ba, we had defined different mnemonics on that one. Oh, ano ba mga to? The application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So that's the open system interconnection model. This is the 7-layer. When I was reviewing for my ECE board exam, I created a mnemonics for this, for me not to forget this different layers. So we have pag di na tumakbo si Pangulong Arroyo. Yan. Those were my days, 2005. Okay? So, of course, there is another mnemonics from our Asia Open RAN. So they term it, all people seem to need data processing. O, ayan. So yan yung mnemonics niya. Ako kasi mas gusto ko yung mga kakaiba na mnemonics eh. That's why I defined that when I was reviewing for my ECE licensure exam. That's so cute. And it really helped because there are 5 questions in the comms side na lumabas ito. Okay, maybe you're wondering, ano ba ang physical layer? So ito yung transmission reception ng signal. Ayan yung cell site to device mo back and forth. Okay? Ang data link naman, this is responsible now to deliver, okay, a reliable transmission, okay, of information either on the different transmission media using a specific protocol. So you have a protocol for Wi-Fi, you also have a protocol for cellular mobile. And then you have your network layer naman. So what does that network layer do? So the network layer now is responsible in routing, okay, data between different network elements, devices, okay, using your IP or MPLS protocols. Okay? You also have now your transport layer. Ano ba itong transport layer na ito? Magkapareho ba siya sa data link? Hindi. It's responsible now of transferring data efficiently, okay, between devices and your network that you are using. So, such as TCP/IP or UDP. So, yan yung mga sample na parameters used on a transport layer. Then your session layer. Okay, session. Diba? You are establishing a connection and then managing now the communication between devices, okay, on a network using the protocol. And then presentation. So you're presenting now what you had captured, what was being sent, okay, by the device. Okay, you are now, this layer is responsible in formatting and presenting now the transmitted information over the network, okay, using protocol like ASCII or even JPEG, okay, more parang compression, decompression of information. Now, the application layer, the highest most, it now provides a high-level service. Okay, app. Parang mobile app mo, yan. Okay, such as email, web browsing, ano pa ba? Voice calling. Okay, yan na yung product mo, kumbaga. Okay, that's where the application layer is. So each layer, they are very critical, especially when you go on Open RAN. Because this is now where you enable, okay, the mobile device to be connected to the different network elements in an Open RAN architecture. Okay, so this is a table showing you now the different equivalent, okay, of your 7 OSI layer, okay, mapping it to the different functionality and equivalent example of the protocols underlying each and every layer. So there you can see the first 3 layer, okay, that's where most of the open radio access network operates. That's where your radio resource, okay, is being processed, okay, your radio link control, the air interface, okay. So all these things works within that first 3 layer, your physical, your data link, and of course your network layer. Now, each one correspond to a role in each and every layer, as you can see, and the functionality. Okay, so as I emphasized earlier, your physical layer, that's where your transmit and receive happens. Okay. From device to your base station to your device. All right, now your 7 OSI layer map towards now a representative view in an Open RAN technology. So of course, you also have now the definition where physical layer is located, the data link and network layer is located. So in RRU, going to your device, okay, that's where the functionality of your physical layer operates. It converts now your RF frequency signal from analog to digital, and of course, vice versa. Your data link, um, that's where the protocol are being used, like the RRC, PDCP, or radio link, MAC, physical layer. So these are where these protocols will be operating on the BBU segment. Okay, the network layer, where it includes now your radio resource control, that's your RRC. It's responsible of controlling the access to the radio resource of the radio access network. Take note that your base station contains now, okay, the specific channel. Once it broadcasts, once the cell site will release the broadcast channel, hey, I'm available. Okay, so you can now transact. Okay, you have your signal. Okay, your phone will handshake to the cell site, and you can access the internet, you can initiate call, or you can send SMS. Okay, every now and then, nagbo-broadcast yung cell site natin. That's why may signal bar tayo. Once broadcast channel is stopped, wala kang signal bar na makikita. Okay? Then, thereafter, once the resource is available, you can now do the transaction, initiate the transaction. Okay? So once there is a traffic or congestion, yan, mahirapan ka makapasok sa network. Right? So the physical data link and network layer during the course of the operation of an Open RAN, no, it now enables more devices to be connected, to transact, and of course, to access each and every technology. Okay, so this is the most exciting part, no? Where we're gonna understand the ORAN functional split option. So there are 8 options. Maybe you're wondering, ano ba ito? Split architecture is a key feature in an Open RAN technology. It enables now flexibility, scalability, and also efficiency. That's where the promise of ORAN is. Efficiency on network element deployment is spectrum based on the availability and power efficiency. So this is something that most operators are waiting on the result of the promise of Open RAN. Now, the architecture is designed to separate now your user plane and control plane functionalities, okay, within the given designed network. And it allows now that you will be able to process and manage them independently. So user plane, control plane. So ano ba ito? Sa mga user, mako-control ng network. Yan. So the split architecture, no, let's focus on the 5G technology. It has 2 main domains. One on a central unit, that's why earlier, ayan, meron kang central unit and distributed unit. Okay? The centralized unit is the control plane function. Okay, that's where you're going to process all this functionality. From session management, mobility management, authentication of your SIM card and your transaction, if indeed it's valid, and of course, your DU or distributed unit, no, this is focused on your user plane. It includes now data transfer, processing of your data, and likewise also the packet that is being transmitted where your information is embedded, where your transaction is being processed. Okay? So, the key benefit that ORAN promised as part of this split architecture is that it enables now more efficient use of the network and cost-effective network architecture. Okay? So everything ended up into cost. Now the big question mark is, when will you realize the promise of cost efficiency? So it's something that all of us are awaiting. Even me, I don't know the answer. Okay? So this is the representation of your radio unit, centralized unit, distributed unit split. Oops, sorry. Okay? So the separation of function within a radio access network architecture, comparing now your conventional approach with the Open RAN systems architecture, you can see the inclusion of your mid-haul and expansion, okay, through disaggregation of your backhaul and your mid-haul. Okay? Kasi ni-split mo na yung RRU mo and BBU mo eh. So, kinlaudify mo na rin yung capability and interconnect mo ng DU and CU. Okay, dati on-prem siya. Okay, everything is being processed on-premise. Parang server on-premise. Now this time, may cloudification na mangyayari. Okay? through an assigned virtual machine, that's where you're gonna put all the store and compute and processing of information. Now, the biggest challenge here I want to emphasize is multi-protocol yan, given multi-vendor. Assuming na nag-deploy ka ng systems architecture na ganito, okay? So, magkakaiba yung vendor, o, di ba? So, they need to be aligned with each other so that there is what we call handshaking. Okay? Mag-handshake sila sa isa't isa. Otherwise, you have a very big problem when you do upgrading, when you do processing, there will be feature set that won't be available because the other vendor is not capable of. Unlike kasi sa conventional network, one single unit, everything processing there. So once there is a feature set upgrade or model upgrade, okay, so may bagong software, okay, you do the software upgrade and licenses, then automatically through logical processing, ma-upgrade mo siya. So Open RAN, the reason why I put emphasis on this is that it's not where we just don't talk about the all positive or advantages of using this, but also let's put the in the playground, you know, the balance ideas of having the challenges also of multi-vendor, multi-system approach. Okay? So of course, it will bring efficiency also because it will reduce the processing of power requirement when do processing kasi nasa cloud na, hindi na siya on-prem. The more you process information kasi on machines, the more power it requires and utilize. So that's efficiency also. Okay, as one of the advantage of the promise of Open RAN. Now, by splitting across, no, it also creates flexibility. So, assuming na yung isa may capability na ganito, so the other one can also, you know, augment it. But in principle, they need to be aligned with each other and follow timetable also. They need to sync in terms of when to upgrade each and every element, when to do software upgrade, okay, so that everything will be synchronized. Okay, so when you separate now your physical and control functionalities, mobile network operators can easily deploy and manage their network capacity and coverage. So as you can see in this systems diagram, no, or network architecture, your physical layer of the radio access network, including your RF and processing and transmission, they are all being done by your radio unit. And the rest of the processing between your user plane and control plane, in case being done by your distribution and central unit. So there you can see, how the different functional split, okay, options for a 5G technology deployment. Ito yung nagiging complicated na siya. Kasi each split has corresponding processing functionalities or capabilities. And once na, it depends on how you select what kind of split you're gonna implement. Okay, either split 8 or split 7. There are pros and cons. So the layer 1, 2, and 3 functional split in that 5G systems architecture for an Open RAN, they are subdivided into layer 1, the physical layer, layer 2, data link, and of course, layer 3 as your network layer. So, by separating across multiple layers, this layer 1, 2, and 3 functional split, it enables now flexibility and scalability of deploying upgrade
Okay, dyan siya nagiging advantage. Kasi logical software upgrade. Once there's a need for more capacity, then i-encode mo, tapos makakapag-deliver ka ng more capacity. Kapag less capacity, gusto mo i-downgrade, so mabilis na lang yan. And of course, what's critical here is yung features niya. For as long as vendors are aligned, okay, with the protocols and with the type of softwares, okay, and they are also okay with the different feature set, anything na you will upgrade on the feature, mabilis siya i-process, mabilis siya i-implement. Okay? Kasi itong makikita mo na based sa split, okay, what needs to be activated, where to activate it, and what functionality needs to be upgraded, needs to be introduced. And the best part here is kapag may bago kang feature na gustong i-implement, okay, you just need to develop it and then outright, okay, ma-define mo siya sa split na to. Okay? So this next slide, it shows you now the disaggregation of each and every network element, which is crucial feature ng 5G. Okay? So you can see CU to UP and CU to CP, control plane and user plane disaggregation, ay ibig sabihin nun, okay, you can see in this pictorial representation how it evolved. Okay? So more important, no, the control plane now will enable a flexible session management, mobility management, and authentication. And also they can deploy, mobile network operators can deploy easily any feature set, any upgrade, any capacity upgrade that's needed, okay, within the area where this disaggregation is implemented. So the DU disaggregation naman, as you can see at the middle portion, okay, you are separating now your distributed units, okay, function from your radio unit functionalities within the whole radio access network element. Now, both disaggregation solution, they are critical features now in the development of new services. So yun nga, in-emphasize ko earlier, pag may bagong feature set or may bagong service kang i-implement, so mas efficient to use this kind of architecture, mas mabilis i-implement. Okay, yung time to market mo, mas okay. And you can manage the different network elements. Okay, so next slide, as you can see now, how it's implemented on a horizontal space, defining now how much in kilometers or how long in kilometers can the interfaces be implemented. And also the latency. Latency plays a vital role, especially when you do, streaming, when you do low latency applications. Okay, the lower the latency, the more real time your transaction is. The better yung view mo sa video, sa image, especially when you do broadcast, no buffering. Yan yung mga impact niya. There's a point here on the centralized unit where you can deploy multi-access edge computing. Ano ba to? Multi-access edge computing is bringing some core capability nearer to the site or on-premise. Okay, so the supposed store and compute capability, let's say, for example, dadalhin mo na siya dyan. nearer to the customer or nearer to the site. Why? Okay? It improves latency. It lowers down now your latency. Kasi the processing is done nearer to the customer. Okay? So overall, the concept of your mid-haul, front haul, and back haul, okay, in a 5G network, it enables now different components of your network architecture from device up to the core network, no, to work together to deliver much higher bandwidth, easily upgradable, higher efficiency, low latency, and a more reliable data transmission because you can monitor each and every network elements. Okay? So, citing this example, no, traffic split 7, you'll use this kind of model. So, traffic split 7, it means that you are splitting now the traffic on a more efficient use of network resource where lower layer traffic, including physical downlink controlled channel, no, and the physical downlink shared channel, okay, is being processed at the centralized unit, while the upper upper layer traffic, this is now being done, you know, at the distribution unit. Examples are the radio resource control or the RRC, and then of course the packet data convergence protocol or PDCP. Now with this kind of split, you would be able to enhance now, okay, the interoperability, and at the same time how you'd be able to upgrade, you know, the feature set more efficient or faster. So another example, no, is the traffic split 8. So the difference naman is that lower layer traffic, including physical downlink control channel, physical downlink shared channel, is being processed at the central unit. And of course, the upper layer traffic, that's the RRC, and packet data convergence protocol. Okay, it's processed on the radio unit. Right? And on a logical view, sorry, medyo blurry yung ibang items, no? But yes, this split that you can see, option 2, for example, it involves now the deployment of a 5G core network and 5G node B only. So no distributed unit or no centralized unit component. So direct yan. Magta-traverse kagad. Okay? It in a non-standalone naman na architecture, no, it leverage on the 4G LTE infrastructure to provide now your 5G coverage and capacity. On option 5 naman, for example, this option involves now separation of your user plane and control plane functionality within a distributed unit. So there you can see, okay, or medyo liit. And then, of course, the control plane function, ayan, are processed at the centralized unit while user plane function are processed at the central unit. So moving forward, no, if we evolve going to 6G, I'm sure feature set will be more, okay, capability and services that can be offered will be much expanded. And then lastly, of course, more efficiencies on power, on features, and of course, on the capability of the solution.